See here in this problem, here for a load, the average power is given as 1.63 kilowatts and power factor is given as 0.862. So then how can you find the apparent power, reactive power and complex power for the given load? And this is the problem. We know that complex power is represented with S and reactive power is represented with Q. The magnitude of complex power nothing but apparent power. It is magnitude of complex power. Now I am going to find the apparent power. We know that the relation between apparent power and average power and power factor. So that is apparent power equal to average power divided by power factor. So here average power is given as 1.63 kilowatts, that is 1.63 kilowatts divided by, and power factor is given as 0.862. So by simplifying this, we will get 1890.9513 voltage ampere. This is the apparent power for the given problem. Now I am going to find the reactive power. So reactive power Q equal to, we have one relation, that is apparent power into root of 1 minus power factor square. Now substitute here. So here we got apparent power, that is 1890.9513 into root of 1 minus, so power factor is given as 0.862 square. By simplifying this, we will get reactive power equal to 485.8913. The units of reactive power is var. Now how to find the complex power? So complex power S equal to nothing but average power plus J into reactive power. So here average power is P is given as 1.63 kilowatts plus J into Q is, we got 485.8913. The units of complex power is volt amperes, and for apparent power units is volt amperes, and for reactive power the units is volt amperes reactive, and for average power the units is watts. Here volt ampere. This is complex power. This is complex power, and this is reactive power, and this is the apparent power, and this is the process of simplification. And thanks for watching. Please subscribe, like, share. Thanks.